This is a continuation of the June 2015 Edexcel International S1 paper. This is mainly about the discrete uniform distribution. For a discrete uniform distribution, we need a number of things. We need it to be equally spaced and for there to have equal probability. So really, if it's defined over the values 1, 2, 3, and I was to draw the probability distribution up as a table, I would just have 1, 2, 3, 4, and it would all, because there was an equal number of outcomes, 4 outcomes, they'd all have probability a quarter. So F3, which is the cumulative, we saw that actually back in question 1, F3 is a combination of these three altogether, those added, because it's the probability of it being less than or equal to 3, which is why it's only a 1 mark question. It wasn't necessary to draw up the table. I'm just doing that by way of explanation. Now part B, you might choose to do the multiply this by this, this by this, this by this, this by this to work it out, but really that would be kind of a bit of a waste of time. There is a formula for it, but even that is not particularly needed, n over n plus 1 for this type of distribution. We can just go halfway in between because it's uniform. So the mean is 2.5 because it's definitely halfway in between the numbers. So done halfway is 2.5. It's only that because of the equal probabilities and equal spaces, of course. Okay, part C, right, now it says show the variance is 5 over 4. Now there is a formula which is quotable for this, but so it's not in the formula book, and that is n plus 1 over n minus 1 over 12. So that would be equal to, because n is 4 here, n is the total number of numbers, so that's 4, so that's 5 times 3 over 12, which gives us 5 over 4, which is fine. I'm wondering how many of us are going to remember that. So the alternative is to use the ex squared, take away ex all squared, that formula, and that is in the formula book or a version of it. And then at least then we don't have to worry about remembering this thing. Then we would just do 1 squared times a quarter. From here, 2 squared times plus 2 squared times a quarter, plus 3 squared times a quarter, plus 4 squared times a quarter, minus 5 over 4 squared. And that's going to come to 5 over 4. Also, not 5 over 4, 5 over 2 squared there, the mean squared. And that's going to come to 5 over 4. Okay, so that's the alternative. A bit slower, but I'm wondering how many of us would remember that. But it is quotable if you do. So you can take your pick on what you prefer to do here. Right, now it moves on. It says there's another distribution here, y, which has got distribution 3 plus k, 2 plus k. So we've got y defined over these values, 3 plus k, 3 plus 2k, and 3 plus 3k. Right, now it tells us a few things, and we're writing the probabilities down for each of these. So each one is a quarter, because again we've got 4 outcomes. Get rid of the quarter there. So the answer to that is a quarter. P y equals to y for all of these values is equal to a quarter, because it's uniform discrete. Okay, I'm just going to make a little bit of room so I can get the other questions done. No, it's a party. They've given a bit of help by giving us the transformation here in terms of k and c. So the variance of y is equal to, remember when you working out the variance as a linear combination of another discrete random variable, anything that you add on doesn't affect it. So it's k squared, the variance of x. So that equals to 5 over 4 k squared. So that's question E done. Now F, it says it's only 1 mark, so you wonder what they're looking for here. They say express C in terms of k. Well, we now know that in order for this to work, we know that all of these have got to be a transformation. So this number corresponds to this number, and this number here corresponds to this, and so on. So I could use any of these as my transformation. So we've got, if I let y be equal to the number there, so y in this case is 3, and x in this case here is 1, so y equals k times 1 plus c. So it just gives me c equals to 3 minus k. That's kind of confusing for a 3-mark question. But you would find the same if you did this for, I mean, obviously we've done the question, but imagine you decided for some strange reason you were going to compare the last one of each of these. Well, then we would have x is 4 and y is 3 plus 3k. So you'd write 3 plus 3k is equal to k times x, which is 4, plus c, and you'll get the same answer. Okay, make it a bit more difficult, but it doesn't really matter which one you choose because each one corresponds to the one from the original distribution. Okay, let's have a look at the next question, question 7. Okay, so it's a correlation question. It's got a scatter diagram, so it's almost like 2 bonus marks here, because surely everyone can do a scatter diagram. However, I didn't mark this, but I bet you some students just got some of the points wrong. So we've got 32, 18 here. Make sure we're marking the correct one. So 18 is along the x-axis. So 32, 18 will come. Each one of these is 2, and that's 18 here, so 32, 18 will go there. Okay, I'm not going to explain each one of these, so I'll just do the answer now. Okay, so this is that approximately right, so that'll do. Then it says the doctor decides to leave out patient's H from the calculation. H is this one here. And hopefully it's pretty obvious. Any sensible answers it's saying here. H is an outlier. There's only 1 mark, so that gets you the mark, but it's always good perhaps to try and say, put it in context, just in case. So the blood protein and body mass index, so which is B, so the blood protein level is unusually high, but that wasn't required in this particular scheme. Looking at it, the blood protein level was unusually high for this patient. Okay, that is one pretty easy mark. Now, then it's to work out the product moment correlation coefficient. Now, that formula, I've probably back in an old question somewhere, we'll find it. The formulae, there we go, all the way up there. We can see there's a formula given in terms of SXY and SXX. Notice the XXX, that's the what's the one that's along the x-axis here, sometimes called the independent variable. SXX is the one on the bottom, so we must make sure that's the one on the bottom. So we've got the dependent one is, oh, I've read off the wrong one. I gave the value of b. Let's go back again. It's this. Obviously, we're back on correlation there. It's that, which so there's not actually too much to worry about here. The one with the two different variables on the top, and then that on the bottom. So let's shove through this. Sorry about this. You get to see the whole paper. Right, so there we go. We can say for C, R equals to the square root of SBP, that SBP over the square root of SPP times SBB. So that equals to 369 over the square root of 423 5/7 times by 490, and that gives 0.809826, blah blah blah. Let's give 3 significant figures. Okay, so that's the answer to C. Not difficult. It's a nice easy question compared to some of the other stuff here. Bit of relief in, towards the end of the paper. D, without any further calculation, state how R would differ from in part C. It's only 1 mark. Well, they're going to be more spread. They're going to be more scattered. So there's going to be less correlation. Remember, R lies between -1 and 0, and and 1. And the closer it is to 1, the more correlation there is, or -1 if we're talking about a negative correlation. But if there's no correlation, it's going to be closer to 0. So this will reduce the correlation, so R would go closer to 0 is the answer. There were other, if you just said that, it gets smaller, that was accepted, or even if you said would indicate weaker correlation, that was accepted here as well. Okay, so, right, the next question I think we will do in the next video. It's on histograms, and it's quite a long question, so we'll do that in a separate video to come.